Afternoon session. Our first speaker is ဋ̇αnγuαgεs, who is a passionate second-year computer science and math student and tutor at the University of NSW. He's tutored Python programming to high school students through the National Computer Science Summer School, the NCSS Challenge, and UNSW Comp Club. When he's not doing the work he's supposed to be doing, he dabbles in security, crashes lectures he's not enrolled for, and noms on Subway cookies. Please make him feel welcome.
Hello. Hello. Hi. I'm Evan. I'll be talking about this. Cool. So this is my second PyCon, and it's really awesome. I loved it last year, and so I decided to come back this year. And this will be my first conference talk, which is exciting and scary. But yeah, I'm here because text processing is awesome, and Python does it so easily until you get oh. Oh no. Until you get stuff like that. Yeah. So join me in part of my adventure in trying to figure out why. So first let's learn about strings. Ooh, this isn't going to work well. Cool. Okay. I hope that's still readable. So strings. In Python 2, all strings by default were in bytes. And then we decided that if we wanted Unicode strings, we'd start them off with the U literal. Now in Python 3, it's the opposite. All Unicode strings by default are Unicode. And then if we want strings that are bytes, we have to denote them. It's easy, right? Sort of. Even with all the Unicode support in Python, we still come across errors multiple times. And Python 2 will do implicit conversions for you, which is why a lot of the time you won't get any problems. Whereas in Python 3, you'll just get errors explicitly. And if you want to do explicit conversions, you have to say so. So what's the difference between bytes and Unicode? So Unicode strings, right? Got emoji. Got foreign languages, got text. Can anyone read what that says? Yeah, cool. Additionally, in the battle of Unicode in languages, you also got the battle of Unicode on OS. Thank you, Surface. So what can we do with byte strings? They have some useful things like this. So they let you index the certain bytes, and you can get the ASCII value of them instead of having to do OR and etc. How do we make byte strings? Well, you can just declare them like this. You've also got the bytes constructor, and you can just exchange a string into a byte string by encoding it with a certain encoding. So in here, you can put something like ASCII, UTF-8, etc. and other ways. If you want to bring them back, you would just do the bytes.decode, get them back in the same way, or just make a string out of them. If you do want to use a string constructor to make a string out of them, you would have to pass in a byte string and also an encoding that you'd like. So something really cool that I did find is that you can do stuff like this. If we run this, instead of having to type 0x, /x, etc., etc., you can just have them quickly converted. So if you are doing byte work in terms of security, you don't have to do for loops and etc. It's handy. So pretend you're me, and you're trying to use these byte things for science. You're trying to smash the stack. What is smashing the stack? In security, we refer to this as buffer overflow. A buffer overflow is like trying to overwrite a piece of memory in your program to get the program to execute different things. So in terms of smashing the stack, we would want to give the program a piece of input that would go into the buffer, and then the program would read that buffer and say, oh, this is different memory now. So you want to specify the bytes that you want to put in to change to whatever you want. you don't really want to do this by hand because you want to say something like, okay, multiply 3 72 times so you can pad out where you want the exploit to start, and then etc. So let's try this. Whoop. Cool. I think it's this one. All right. So let's put it in here. And then you want to read what you've got. So we've got a text file with a bunch of 3s, and then right at the end we have our bytes. But these aren't the bytes that we want. These bytes, VB does not equal to C3, 9, etc. But why? Like, I see this and I'm just like, okay, this isn't what I want. Why does it work for other people? Other people told me to do this. Well, other people use Python too. Cool. If we run this in Python 2, though, it works fine. Why? It's not fair. I just want to use Python 3. So in Python 3, sys.stdout is a text I/O object. And so it's not bytes writable. So when you want to print a string to stdout in Python 3, it first has to be encoded into whatever your local encoding is. And then it doesn't print the bytes you want because the bytes that you did have had to be encoded through the Unicode spec. It's very sad. So this creates a problem whenever anything is trying to write as bytes through print. Oop. So for example, some main solution that you'd find to this online would be something like this. You change sys.stdout to be equal to codex.getWriter UTF-8, which just means grab the stream handler for the UTF-8 encoding, and then detach sys.stdout, and then change that stream to be equal to the buffer of sys.stdout. It's very confusing and ugly. And yeah, help me is what usually you see on Stack Overflow. So yeah, what's a better fix? Well, we can do something like this. Instead of changing what the buffer is, we just say, okay, get the stdout buffer and just write to it. And the stdout buffer, it will just let you write bytes. And so if we take this, I don't want that. Nope. Okay. No, this is going to be tedious. Okay. No. Aha. Oh, wait, I screwed up again. This is so hard. Yeah. Cool. All right, and it works. Yay! All right, so there's another problem though. We never really specified what the encoding is. So by default, the character encoding is dependent on your system. So if you do local.getPreferred encoding, you get the encoding that your system wants and that your Python will take from. And of course, Windows likes to do things differently. If you are in interactive terminal in Windows, it will take a different code page from being in not interactive mode. Fun. So the other things you could do is check out the errors argument. I found this a lot while reading up for this, and it's actually pretty cool because whenever you're doing the decoding, you can specify how you want to handle errors. So by default, it'll be strict and it'll give you an error. You can also have the ignore error argument, which is just forget about Unicode. If we see an error, ignore it. We don't care. There's also replace, which lets you like replace the character with like a question mark or something. Then there's XML and backslash replace. Backslash replace will just replace it with backslashes. And then there's also name replace, which will replace it with a named escape sequence. And surrogate escape, which is pretty cool because it takes the part of UTF, which is available for free use, spits out that into Python, and then when you go to print it again, it will just put them back as it was. Right, you can find more of these here if you want to read them in more depth. Cool, so we've been over Unicode and byte strings. Can we break text processing in other ways? What about F strings? They're new, fancy, right? Well, first, let's take a step back into string.format. But to do that, what is a string format exploit, right? If you don't come from a security background, this is all new, right? So it's taking advantage of the string formatting and being able to execute the code that you'd like. So for example, in C, we have something like this. We have a standard C program, and we've declared a s-char pointer. And then we also have a scanf, which takes in some amount of code, or some amount of text, which can be whatever. And we put it into the string, and then we print the string. This looks all right? Mostly. In C, printf is like, OK, give me what you want me to print and how you want me to print it. And then in the second argument, give me what you want to print. Something like this. If we do something like this, then C will just take literally any string you give it and parse it as it was a format string. So in this case, it would take, say you gave it a string of %s, 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 then it would literally try to dereference the next argument on the stack, which would just be one down, right? And so you can do stuff like this to find strings in memory or change strings as well. Because in C, we have a format specifier which lets you actually write bytes to the memory for some reason. Well, there's a good reason, but it's not really a good reason. So does Python have them? Yeah. So I have a website here, a very small website. It's better. Cool. And you log in, and now you have a box. And the box lets you format things. So what would we do, right? We can do something like hello, and we get hello back. We could do something like input. It's just text, right? But behind this is actually a dot format, right? So we can do something like this, and then get the object that's been passed to the format function. Does anyone know where we would go from here? Well, from the format object, you get its init. And then from there, you get the globals. Yeah, and then from there, like you might see something like users somewhere. Here we go. So let's get the users list. Cool. All right, let's get the second item from it. All right. Let's find the item in there. Maybe they have a field called password. Oh. OK, So can we take this further? Yeah. Instead of going to users, let's go to Flask's app. And then from app, let's go to the secret key. Now we have the session ID's cookie generator secret key, right? So we can use this and impersonate other people and generate our own cookies. Awesome. So behind the scenes, in one of these terminals, that's really big. Good? Okay, cool. So here we have just a user object, which just has some standard fields. And we have some general things. And if we go down, we've just got our basic page. In the page, we go, OK, get the query that they gave in, and then basically just pass it back and do a dot format on it. This seems pretty silly. Like, why would you do this? Apparently, people do this because they want people to actually be able to format how their names come out for some reason. But in any case, all right. So what about these new fancy F strings? They're pretty cool, right? So you can do something like this. And then you get back whatever. Because anything in here is just an expression. Can we break them? Well, to start with, F strings don't have or use locals or globals. And recursive interpolation isn't supported. The compiler will just stop you. So here's a question. What happens here? Is it A or B? Put your hand up if it's A. Put your hand up if it's B. OK. It's A. Why? Well, because string format, the F strings are done when they're, F strings are done as it's being, through the abstract syntax tree. So they're being done as it's being parsed. Before it even gets to the dot format, it will have already evaluated to A, and so it won't do anything. So what does this do? Put your hand up if it works. Put your hand up if it doesn't work. F strings won't let you put backslashes into them. I don't exactly know why. Yeah, I assume it's something to do with how the parser parses them and then won't let you escape the quote and thus go on into things it shouldn't. But yeah, so sad. Can they contain colons? Because if we want to do something like this, right, say we have a list and we want to get the last index or etc. And then we want to format it so it's padded by 10. Does this work? Hands up, yes. Hands up, no. This does work. This is because the colon is inside its own expression, so it doesn't interfere with the string. What about lambda function? Yay, nay? Hands up, yes. Hands up, no. OK. This is fine. Again, it's in an expression because it's in brackets. But if we actually remove the brackets, they'll complain. Spoilers. Nah. OK. So, oh, something happened. So what about this? What if we put an F string inside an F string and then keep going. This looks really messy. Yeah, so does this work? Does this not work? This works. Don't do this. Pro tip, if you're trying to do this, you're going to need all these extra quotes because you're going to need a triple quote to put in a single quote and a double quote so it doesn't break and escape them. And then, yeah, it's going to get to a point where you just can't anymore. I think it's like, yeah, really 3 levels deep, right? Because at this point, you can't, 4 levels deep, actually, because you can't use the single quotes. You run out of strings. Cool. So can we nest f strings? Does this work? Yay? Nay? It doesn't work. In the same way that format strings will stop you from nesting too deeply, f strings will do the same thing. So in this case, we're saying, okay, get the value and then pad it and format it by this much. And then we're saying, okay, the width, pad it by this much. I don't know why you'd want to do this, but you can't anyway, so sorry. So yeah, in general, it's pretty hard to break things in f strings that use user input, like we did with .format. That's provided you don't eval or exec the string. Who would do that, right? Yeah, you could do this if you really wanted to. You probably shouldn't do this. Why? Well, say the user gives in their name, and the name is the name of a file that contains extra info about them. They could very easily just go ... .password, something. In the same way in select or, in the same way in the SQL query, drop tables. So you kind of don't want to do this. How would we fix that? Well, PEP 501 proposes I strings, which are like F strings, except they can be escaped beforehand. I guess that's cool. So now I hope that you all have some extra knowledge and in how to avoid this and this. Thank you.
All right, thanks very much, Evan. Congratulations on your first talk. I think it was great. As a token of our appreciation, as a mug.
Thank you.
And we've got about 3 minutes left, so a quick question or two if anybody has one. Anybody?
Yes.
So you mentioned I strings. What can they escape? Just normal Python things or SQL or anything?
From what I've read, I think it's just what you want them to escape in the same way that you would escape normal SQL strings before formatting them. Yeah, the PEP didn't go into too much depth, but you can check it out.
Cool.
Cool.
All right, anybody else? In the back.
I think in 362 there's some fixes for backslashes in F strings.
Cool.
So you know.
I wonder how they work. I went through the source of F strings, and it's interesting and also confusing. But yeah, cool.
All right, any other questions? Okay. In that case, thanks very much, everybody. Please, one more hand of applause for Evan.